Hi everyone, Steve Ignish here. So this is day 25 of me sharing my learnings and explaining things in English. So as I'm preparing for PL300 exam, the topic for today is model data with Power BI, and the chapter we are currently in is write DAX formulas for Power BI desktop models, and the topic for today is introduction and write DAX formulas. Yeah, let's move on to the notion. So, unlike other chapters, this chapter requires detailed explanation about its introduction because it has some serious values. Yeah. What is data analysis expression? So, it is a formula kind of thing which you can include in your Power BI report. It can do various things. We will discuss it. So there are three types of DAX formula you can use. Sorry, not three types. You can use in three ways. One is calculated columns, calculated table, calculated column, and calculate and measures. And let's see the calculated tables first. So what is a calculated table? A DAX formula for calculated table creates a new table in the model by transforming or duplicating the existing data, increasing the storage size and refresh time. So it is nothing but a table and that is additionally created by a formula. It will store in the model and it will use the refresh, and also it will take some time to uh, you know take the storage. So that's why it takes some little more time to refresh the data. So calculated tables are the things that is stored in the data. So when you are using the import, so when you are using calculated tables, it automatically take the import mode and will be stored in your model. And so calculated tables can be used in various scenarios. Let me explain. The one thing is enabling a transfer date tables. So we have seen it previously. We have did also created a calendar table in previous video. So you can check out that. So if you don't have date table, it is hard to find the do the analysis by months and dates. So in that case, you can create an entire date column, date table using the calendar and calendar auto function. So that's how the this DAX calculated table is used, and role playing dimensions. So when two model table have the multiple relationship. So for example, let's say we have a table. Wait a minute. So we have table like sales and date. So we have a two relationship flowing from a date to sales here, right? So the one is the date from order date, the other one is shipment date. So this is in a table, in a relationship, there is only one uh, active relationship could be there in between uh, the tables. So the another one is here, the dotted line is the inactive table. So while we are using the inactive relationship, you should use a formula like user relationship to determine the for DAX function. So there is another way where you can separate the table. Let me show in an example. So in a sales table, you can separate the date. The one is order date, the other one is ship date. This is used by calculated tables. You can duplicate the date table and you can keep it the date table and ship table as a separate one. So this is possible because of calculated tables. So this is one possible way, and by duplicating this table, the very useful thing here is you can filter the date by even by either by order date, or you can filter by ship date. So this is the benefit of role playing dimensions. So this is role playing dimension, and you can use calculated tables to separate the table and do your analysis even more better. So let's see what if analysis. So what if analysis is nothing but this is a separate option in Power BI. So you can use what if parameters to calculate the tables. It will create a table, and you can use a forecast method to do your analysis. So it is also called as a disconnected table. It will not connected to any other table in the model. but it is an table that will exist in the model, but it is an table which helps to do some uh, filter or so not filter exactly. So it will help to forecast the data. So if you are having some sales, and if you want to say how the sales would be if I add 1% or 2%, it will show the actual sales and the forecasted sales. So it is an individual topic, and if possible, I will try to make a separate video for that. So then next one is calculated columns. So the calculated tables is over, and the calculated columns is similar to calculated tables, but not it will not return the table, but it will return a individual column with every row. So DAX formula for a calculated column evaluates value for each row, increasing storage size in import mode. It will also increase the storage size in import mode, or if you are using direct query, it will rely on the data source. So let me show another example of calculated columns. So the calculated columns will be in this type. So it will show some sigma symbol here, and yeah, and let me show what is measures. So measures, most if you are using DAX formulas, most of the time you will be using the measures. So a DAX formula for a measure calculates a single summarized value at a query time. So it will not take the storage or refresh time. It will take the query time to load the measures. And unlike the calculated columns, which are evaluated in the storing refresh time, as we have discussed, the calculated columns and the calculated tables will take the refresh time, but the measures will take the query time. And the measures written in the DAX are explicit measures. So if you are writing an measure with your keyboard, it is called an explicit measure, while implicit measures are that is how to say that, it is automatic by Power BI. So if you are having the some columns, and if you right click, for example, I will show now. So these are the explicit, the calculated symbol measures are the explicit measures. So these measures are created by the user, and the other thing which has the sigma symbol in it, it is by default Power BI determines based on its data type, based on the data type of the column. It will determine the whether it is a whole number or fixed decimal number. It will give the uh, sum, count, and average, like the basic implicit DAX thing. So it is called implicit. And let me show a practical example here. So I think I did not explain this well. So if I do an practical explanation, it will be very clear for you. So for example, if I put a visual here, and I keep the so this is an implicit measure. So this is not created by me. When I import the data set, it automatically creates the implicit measure. So based on its data type, it created a summation here. So if I click and drag this here, I want to keep the y-axis, x-axis. So wait a minute. So it is taking some time. So yeah, here you can see product A, product C, product B, product D, and all. So this is already sum of this sold quantity. I didn't do any summation. So here I can use the summarization is equal to count. If I do count, it will change the order. And if I can do whatever the basic, the maximum, minimum, average. This is all the basic aggregation. So this is called implicit DAX, implicit measures. So what about the explicit? So I will show now. So if I click here and I say new measures, just taking some time. So the in the upper of the bar there is a measure, right? So there is saying that this is a measure. So you can write whatever you want. So if you write like this is called an explicit measure. So I will explain this in a while. And yeah, so these are the basic three things that you can create using DAX. So this is about the introduction. So let's move to the write DAX formulas. So what is writing a DAX formula? DAX formula consists of expression that returns either a table object for a calculated tables or a set scalar value for a calculated columns and measure. So DAX is a formula kind of thing. It will accept the expression and it will give the result based on that. So each model calculation type, that is calculated table, calculated column and or measure, it defined by its name. So if you want to create an calculated column, calculated measures or calculated columns or measures, you can use the name you want and you have to give the input as a equal to sign. So if you give like that, it will be accepted by the Power BI. So let me show a basic DAX syntax. So it is a basic DAX syntax. It is called calculation name is equal to DAX formula. So the name of the DAX formula should be written like this, and you have to say equal to. If you say equal to, the DAX will be started, and the shift date is equal to date. So this kind of things are DAX formulas. So I will show an example, the basic example now. So I go to this, and so you can create measures by using two ways. You can right click the table and click say new measures, or you can go to the table tools and you can say new measure. So if you click like this, it will load for some time. After that, a white bar will appear on the top. So it will be like this, and you can click this to expand this. And if you expand this, it will become more. And if you click Control and scroll up, it will be big in size. So you say total sold quantity. So for this, you can say sum of sold quantity. So if you click if you say the sum, it will give you some options, right? So this is called I don't remember its name, exact name, but it is called so I will go refer the Microsoft website once again. So there is an option. So I guess it is in the next page. Yeah, I think it is in the next page. Yeah, that is intelligence. So there is an option called intelligence in Power BI. When you click the some calculation, so some if you click some function name, it will give the function name, and if you hit tab, it will automatically say the function, and also it will determine, and it will also give the logic or expression that should be after the formula. So this is called intelligence. It is available in the Power BI, and you can easily use the tab to say this, call this, and if you can say like this and close this and say enter. So now the DAX measure is created, and see there is a calculated symbol here. So this is a created DAX. So this is how you should create a DAX function. So this is a basic example I have given now. You can go to Notion. We can clear these things. So formulas are assembled by using. So these are the formulas. Excuse me. So DAX function. So let's see what is DAX functions first. So DAX function is a language where formulas use nested function with arguments passed in parentheses to accomplish the specific goals. So basically, a normal DAX function are determined in this topic, and so this is how a DAX function will be. So it will be say the name, and it say equal to, the DAX function starts from the after equal to, so it says sum x, and it will passes the arguments within the brackets. So this is the basic DAX functions, and you can see the DAX operators. So DAX operators perform arithmetic comparison, string operations, and conditional tests within the formula, with further detail provided later in this model. So this is uh, I am included the readings from the Microsoft website, so that's why I read this too. So for now we'll clear this, and the example for DAX operator are, so the profit is equal to sales, the revenue is equal to cost, sales minus cost. So this is an basic arithmetic formula where you can say the table name and the measures, you can say it, and this is an comparison. So how I say it is in comparison, because it is used if. So if is used in conditional statement also, and also comparison statement. If the my sales revenue is greater than 1 million, then say high, or else say low, like that it is saying. So yeah, this is a basic thing. And so let me give an example for this DAX operators. So let's go to Power BI, and let's convert this to a table format, and the quant, so this in count, and let's say to sum. So our product is like this. So this is our sold quantity. So let's say a conditional format for our products. So I've created a new measure. So I'll expand this for better reading. So I can say condition is equal to. So I can use if condition. If the logical test. So I want to say the logic. So the logic is total. So we have created a total sales quantity. No? So if you click the square bracket, it will show only the measures we have created, and you can click sold quantity, comma. If it is true, if the sales quantity is greater than 100, then sorry. So then say me high, comma, that is else, say me that is low in terms of quantity. So the DAX function is over now, and the condition has been established. So now let's move this condition to the table. Let's see how it reacts. Yeah, if the logic is, if it is the sales quantity, total sales quantity is greater than 100, then show high, right? So we have to say it is above 99. So we say if above 100, it will show only the above 100, it will not show the equal to. So let's say equal to or greater than 100. Greater than should be here, and yeah, so it is taking some time to load. Yeah, after the condition has been written properly, it is showing that the sales quantity is high and this is low. So this is how you should use the operators, DAX operators. And let's see the next one. So the reference to model objects. So there are three types of reference. One is table reference, column reference, and measure reference. So the table reference is, if you write the DAX function is equal to the table name, so it will become the table reference. And if you say the revenue is equal to sum, and you say the column name like this we have written before. So let me show an example. So we have used the function, and you have told the table name and we have selected the column name. So this is called a column reference, and we can also say profit is equal to, this is a measure, right? So this is a straight away the measure, so revenue minus cost. So we can also call the measure in DAX function. So the one thing between column reference and measure reference is you can straightly call the measure in measure reference, that is you can say directly revenue is equal to cost, but in the column reference you cannot do like that. You have to use a function to call the column reference. So that is the major difference between the both. And let's say what is DAX variable. So the DAX variable is a thing. If you know about Python, there will be a variable that will be determine the some of the values in the previous step, and after that it will return some value. Likewise, the same thing happens here. So the profit margin is equal to, you can say var is equal to variable, and you can say the name of the formula, and you can, this name should be anything you want, and you can say equal to, and after that you can say some sales revenue is equal to like this, and you can say the total cost is equal to the sum of the sales cost and the return. So we have to return by doing this operation. So by this this will help to combine all the thing in a same measure, so it will not require a different measure to do a total revenue in one measure, the total cost in another measure, and divide it in the final measure. So instead of doing this, you can call a same call a same measure and do separate the variables based on the you need, and you can call the divide function, and you can do the division activity. So this is how the variable is defined. So let me show an example for DAX variables. So let me show an example for DAX variables using different two tables. So now we have product name, ID, and all. And another table, the sales records we have. So now what we do is we can create a new measure. We can say total sales amount is equal to, and I can say the variable here. So let me explain why the variable comes here. So variable of total quantity so we cannot use a space after determining a var, so it will show wrong, it is wrong, so it is, you have to click underscore, or we should not use any gaps between that. And I'm going to say that the total quantity, so these are the total quantity. So I'm grouping it and I'm doing aggregation, and also I'm doing it aggregation for total, no sorry, price. So is equal to sum of all price. So now I am saying this is my total price and this is my total quantity sold. So let me find the total sales amount. So for that I have to use return. So if you don't use return in variable, when you use variable and you don't use return, it will not return a correct value. And the first variable I have determined is the total quantity, and the second one is the total price. So I have to do quantity into price, that is equal to total sales amount. So this is the variable, return me total sales amount. So what is the formula for sales amount? So let me do it is, so the first one is total quantity into price is equal to sales, right? So there is a typo, where it should be price. And yeah, now we have determined everything, and if you click OK, so instead of doing sum of sales, sum of quantity and sum of price in two different measure, we can, so if you do this in a separate way, it will take three measures to do this process. But if you use variable, it will end up in a single measure. So that is the benefit of using variable in a measure. So let me show an example now. So we have table here, and we can go to the product name and the quantity sold from the product, and so what is the price? So this is the price of the product, and let's see the total sales that we have created now. As you can see, the total price is coming based on the measures we created. So not expanding these measures by using the single DAX measures, we did a variable, we incorporated the variable in the DAX function. It enabled us to get the answer in a single step. So this is the uh, uh, feature of DAX variables, and it is very useful when you write advanced DAX and all. So yeah, that's it I had for this video. And if you are an expert watching my video and find any mistakes or miscommunication, please let me know in the comment section. I'm open to learn from everyone. Thank you.